Hi everyone, welcome to Chem 104. This is the first lecture that I'm going to be doing, and so I just wanted to give you a little heads up on what is going to be going on. I will not read the slides to you, that you can read, your adults, but I will work the problems. I'll give you some time to try them first, and then I will work them for you just to make sure you're on the right track. If you are if you are having problems with something, you can always back it up and listen to it again. If you have a question or a comment about anything, please, you can send me a remind text or you can send me an email. I am very laid back on my videos. I'm not very strict, and so hopefully you will be okay with that technique. I try to make it a little bit fun, so if you are looking for a more serious type of thing, sorry about that. All right, so this is chapter 1, and chapter 1 is going to be talking about basics of chemistry and some of our basic concepts. So chemistry is the study of matter, right? And matter, most everyone has heard this before, is anything that has mass, that is, you can measure how much it weighs, or has mass, and it takes up volume. Okay, so there's a certain amount of it that you can find. Matter can be solids, liquids, gases, anything. Okay, so then the states of matter. The states of matter, you have solids, as I mentioned. Solids, liquids, and gases are what we're looking at. Solid state has a definite volume. It maintains its shape. Okay, so you can put it in a beaker and it'll still have the same shape. It's not going to change shape just because you put it in a different container. And they're very closely packed, as we're trying to show you here. See how closely packed they are? They are in sort of a nice geometric design almost. Okay, and so that's a solid. Liquids are almost as closely packed as solids are, but just a little bit looser. They have a definite volume. They are pretty close together still, but they can kind of slip back and forth between each other. But they do not have a definite shape. That is, it doesn't matter what you put a liquid in, it's going to conform to whatever shape that was. The third state of matter that we talk about is a gas. And a gas, notice how much is between those two, okay? Those four molecules. There's no definite shape, so if you put it in a container, it's just going to be all over the place. It has no definite volume because I can put it in a container, and if that container is where I can make it smaller, like in a balloon, I can actually change the volume of the gas. And notice how far apart they are. And because they're so far apart, they can move around pretty easily, and so they just move around randomly. Physical properties are things that you can see or you can measure. So boiling point, odor, things like that. The state is also a physical property. And so if you have a physical property, then you can change something about that material and alter that, but you don't change what it is. That is, its composition is still the same. So if I have a water molecule and I melt it, I can change it to a liquid water molecule. Now this we call ice, right? This we call liquid, and then we can either heat it up even more and turn it into a gas. The physical change, it went from one state to another, but it was still water. It was just water vapor, water liquid, or water solid. Chemical properties, on the other hand, are in order to find a chemical property or for it to go under a chemical change, you're going to change it into something other than what it was once before. So if you have a chemical property, you're going to be able to convert that by changing that into something else. And so the example that I have here for you is that I have oxygen and I have hydrogen, and they're separate things, and then I react them. And then when I put them together, I still have hydrogens and oxygens, but now they're recombined to form water. So since I changed it from one thing to another, that caused it to be a chemical change. All right, so here are some questions, and this is where you can stop the video for a minute, see if you can answer these questions. You may not be able to because we haven't talked specifically about them, but go ahead and stop the video and I'll give you a chance to answer these and see how you did. All right, if you stopped the video and tried, we'll go over them. If you didn't and you're cheating, okay, whatever. All right, so when a solid changes to a liquid, it is called what? All right, so when a solid changes to a liquid, what is that process called? It's called what? Melting. Melting. Whew. My pen is off and it looks like I'm on drugs or something. All right, liquids, true or false? Liquids are easy to compress. False. You cannot compress liquids. When a gas changes into a liquid, what is it called? Okay, so it goes from gas to a liquid. What do we call that? We call that condensation. All right. True or false? Particles of a gas are packed tightly together. That's definitely what? False, because they're the most far apart of any of them. Wow. My pen is like not exactly lined up on my thing, so that's why it looks kind of weird. When solids reach their melting points, they become what? When they reach their melting point, what do they become? Liquids, right? Liquids. True or false? Plasma is a state of matter. It's actually true. We don't talk about plasma in general chemistry because it's a little bit above our pay grade here, but it's the fourth state of matter. When a gas reaches its condensation point, it becomes what? Condensation means it's what? Like if you think about a pot of water boiling and you open the top and you've got those little beads of water in there, it's when the gas becomes a what? Liquid. All right. What is it called when a solid changes directly into a gas? Solid goes from solid to a gas. You see this in like dry ice where it goes directly to a gas. That is called sublimation. I can't even get it all on there, sorry. Sublimation. True or false? Gases are hard to compress. False. Gases are very easy to compress. All right, how'd you do? All right, this wasn't something that you necessarily knew. This was kind of like a prior knowledge thing. So I'm just letting you know these instead of just going through other slides, okay? All right, so we're looking at the differences between chemical and physical changes on this slide. So does the molecular art represent a chemical change or a physical change? Remember what the criteria is. In the criteria, we have to what? It has to stay the same thing if it's going to be a physical change. It will change composition if it's a chemical change. So I have some molecules over here, and then I have different molecules over here. So what does that tell me? It must have been what? A chemical change. All right, so let's look at these. When you have the trees changing color, is that a physical change or a chemical change? The color change is physical, but there's a chemical change going on in those leaves that cause them to change color. What about, so that was, we said, is a chemical change. What about an ice cube melting? Physical. What about bread mold? What's happening is the mold is eating the bread and converting it into energy and then growing. So that's definitely a chemical change. What about fireworks? Fireworks would be an explosion. That's definitely what? A chemical change. Rusting nails? Chemical change. You're changing iron to iron oxide. What about boiling an egg? Is that a physical change or a chemical change? It's a physical change because it's still an egg. It's still got all the components. We just basically changed it from a liquid to a solid, right? Okay. So you kind of get the idea. All right. So we're going to classify matter. In matter, everything is either going to be a pure substance or a mixture. All right. So a pure substance means it's just all one thing. A mixture means it's more than one thing, right? Makes sense? Okay. So if it has constant composition, that is, it doesn't matter if I had a bowl of it and I took a sample of in all parts of it, I would always come up with the same exact thing, and it's only one type of atom or molecule. Okay, so it's one single component. Constant composition, no matter how much I have of it. I can't break it down physically, okay? I can't break it down to anything else physically. So a pure substance could be table sugar and water, okay? I put table sugar and water and they are both pure substances and I can mix those together. Now, I probably misspoke when I said that because what I meant to say was table sugar and water are both pure substances. But when I mix them together, what will happen? Will it still be a pure substance or will it be a mixture? It'll be a mixture because now I've put two pure substances together, and so now I have more than one component. So my molecules, we're going to mix and they're going to make a mixture. They can have varying composition and they can be separated by physical means. So like if I have sugar and water together, what I can do is I could boil that and eventually all the water would boil off and I'd be left with sugar. That's physical, boiling it. Okay. Make sure I'm going the right way. All right. So the sugar dissolved in water is a mixture, as I said. A pure substance is classified as an element, an element or a compound. Okay, so it can be one type of atom or it can be more than one type of atom, but they're all molecules. So that is, they're all the same. Okay, so water is a molecule, for example. All right, if it's an element, I can't break it down any lower by chemical change. So the element is something that we're going to see on the periodic table, if you've ever heard of that. And those things that are listed, that's a pure substance that is an element. The compound is when I mix two things together. Like my sugar, for example, is a compound because I've joined two or more things together. So this is just like kind of a flow chart for you to look at. In matter, okay, can I separate it physically? Can I separate it physically? If I can, it's a mixture. If I can't physically, it's a pure substance. If it's a pure substance and I can't break it down physically, can I break it down chemically? If I can, it's a compound. If I can't, it must have already been an element. Okay, so that's kind of how you can use that to remind yourself of which is which. All right, so that will be the end of the first lecture. Thanks for hanging with me. Part 2 is coming up in just as fast as you are going to watch it.